switch over to this screen here. And we are live for our second edition. Welcome, everybody. Second edition of InSession, with, again, a nice program that we've prepared here. Two different projects that we'll look at. But maybe first of all, we'll have a look who are the hosts of this InSession today. So I think I'll point diagonally. Oh, wait, this way. And Isabel is going to start. Who is with us today, Isabel?
Oh, who is with us today? Today we have Akiko Yamashita, a Japanese artist best known for projection mapping and light installations, currently based in LA. And we also have Torin Blankensmith and Peter Whidden, developers from Shader Park. And Peter's joining us from Seattle, and Torin is joining us from New York. Akiko Yamashita, Japanese artist best known for projection mapping and light installations.
Oh, we have somebody feeding back here. Somebody's listening to the YouTube stream.
Somebody watching the YouTube stream.
That's not me. We'll get it right, guys, very soon.
Yeah. But what I actually thought we maybe talk about is who is here from the derivative team today. And Isabel, if you start,
I'm going to start. I am going to introduce our latest developer, Rob McConnell, who joined our team about just over a year and a month ago. Prior to that, Rob was president and lead developer at Longbow Games, where he worked for 17 years, starting right out of school as a lead programmer. And we're really happy he stumbled across our job posting for a developer a year ago and found it to be very full of technical challenges and variety, and somehow exactly what he was looking for. So he joined our team, and we're super happy about that because Rob is a high-speed, very prolific developer. He's been developing all things to do with point cloud, like the FITS files, Connect Azure, Ouster LiDAR, and some camera tracking with Stipe, and a few other things that haven't been released yet. So.
All right, thank you. I guess I'll jump over. I'm going to introduce Malcolm. Malcolm, probably, as a lot of you guys know, is our resident guru on everything rendering and video playback and streaming. He's been with Derivative since 2002, I believe. I think we were both probably wandering around the Waterloo campus as students around that time. And yeah, he's responsible for keeping everything moving quickly under the hood and has showed me ways to use a graphics card I didn't even imagine of when I was doing game development. So I'll pass that along.
All right, thank you. We also have Ivan here. Ivan lives in Oregon. He's our resident Python expert. He's most notably known for creating the TD Ableton integration environment, which we're going to be talking about today. He also does stuff like the component editor and the widget kit, and lots of the UI overhaul and lots of the UI design as well. And he also runs a community theater and art space, I think, if he would describe it like that in his hometown.
Yes.
No.
Okay, I didn't know we were passing it around, but I guess I will introduce Jarrett. Jarrett, the founding member at Derivative, and an artist and overall systems designer, kind of software designer behind the scenes, and also kind of an expert at working like optimization and working out the really tricky stuff on projects. Done huge projects with Disney and is also the person that introduced me to the team and changed my life for the better.
Well, thank you, Ivan. You changed my life as well. Thank you for coming. Yeah, Ivan and I work very closely, obviously, on things, and he's the heavyweight Python guy, so we wouldn't be able to do much. I wouldn't be able to do much without him. So And Marcus, I introduced you last time, so
I know, Ivan, you didn't get the email. It's the list who introduces
Yeah.
who.
Oh,
You
I
you
guess I
have to do it
didn't.
again.
Marcus.
Okay.
What's new about Marcus? Well, he does all of
Very weak.
our online in-session streaming stuff. I think he knows he's tested every single Google, Facebook streaming solution so far. We're getting better and better though, and so I hope everyone's
so.
I hope the quality's gone up because Marcus has been working really hard on this. So thank you, Marcus, for push this
Thanks,
stuff
Jared.
forward.
Yeah, we well, it takes a community to figure that out. It's with input from Albers and Roy and everybody, and then things like, well, lots to talk about there. But really nice that it's now seems I think we have a way now of working with. So I'm introducing Isabel again.
Oh yeah,
Still can't figure that out. Where?
I'm
Doesn't
above
matter.
you.
So, Isabel, you worked at the Beale Institute before, right? A
I
long time
did.
ago,
I
where you did a
did.
lot of research as well. And this kind of brings you, or brought you then to derivative, and that comes in very handy when you do research on topics that directly affect the business and community environment that we are in. Because I think some of that research overlapped or is consistent
Yeah,
for the two.
yeah. I would say so. I'm happy to be at derivative though.
Yes, we're happy you're here. And yeah, so with derivative, you're, as most people probably know, you're very much in charge of the community and keeping the community together. So yeah, is that good?
That's good. I think the community keeps itself together pretty well, but
As
thank you.
well,
Yes.
yes. It
I
always
like
though
working with
needs
the
like
community.
a
Yes. Yes. Someone.
yes. Excellent. And with that,
So,
maybe we'll go to our next point of today, which is a little explanation on what actually InSession is. So what, because it's only the second time, so we thought maybe we'll go over this again. Well, I can start, I guess. So we came up with this InSession thing as a way of getting direct or spending direct time with people from the community. And the community can submit their questions and projects. And we're going through these submissions and then picking some that we think would be very valuable for the whole community, and then spend 45 minutes discussing those. Yeah, Isabel, anything else on that topic?
yeah, I mean, I think you guys kind of know by now. You go to InSession on the derivative website, and you will find a form to fill out. And the more explicit you are, and the more direct and technical your questions are, the more likely you are to find yourself here one of these days with us. So I think that's it.
Yeah, exactly. It's really nice to get some, if we can spend some time on a topic and go deeper, and basically also pick the brains of some of the people you don't, or you not that often see online in person. So it's a great opportunity.
Absolutely, yeah.
So spend some time when filling out the registration form, spend some time actually thinking about the questions and things. And with that, yeah, I mean, it's, just to say again, it's really easy to find. Just type InSession into the search at the top of the browser of the help of the derivative website, and then InSession should come up pretty much as the first entry there. Easy to find. All right, with that, we already said who's with us today. And the first one we'll be talking to is Aki.
Aki.
So hello, Aki.
Hi, Aki.
Thank you.
Thank you so much for joining us today.
Yeah, thank you for having me.
Who's your banana robot friend over
My
there?
friend, yeah, this way. Yeah, it's actually everything, TouchDesigner, rendering, real-time banana.
Very nice, very nice. For those of you who don't know Aki, I sort of quickly introduced her earlier, but she's a Japanese artist who moved to LA 10 years ago.
Almost, yeah, it's
Almost.
been 9 years.
Yeah. And you also work as a technical director at VT Pro Design on some super cool projects that take advantage of the latest technologies like robots. And we'll get back to that in a sec. But I was looking at your website, and I really like how you describe your work as artworks that explore visual illusions with prism-inspired full spectrum of colors.
Yes,
Can you say anything about that, or should we get to robots?
Well, I think Marcus looks like just got the image too, so maybe I can talk a little bit about things I have been doing. Yeah, I got in doing from projection mapping actually, and I really wanted to do projection mapping, so that's why I learned 3D, kind of everything in general, doing modeling to animations and then eventually I ended up using TouchDesigner. But I also have a dancing in background, so for me it was very exciting to be able to do real time, and also using something like Kinect and use a body movement to drive some visuals.
Right.
Yeah.
That's cool with a dancing background. And you've also won an award for your portal in downtown LA in Japanese town, Japan. There it is.
Yeah, it's this one. Yeah, this is in Little Tokyo, in downtown LA. And yeah, these pixels are like actually animated with TouchDesigner as well.
Yeah, it's a beautiful project.
Thank you.
So what are we getting into today with VT's robot music project? What's it about, and what are you trying to achieve?
Yeah, so VT Pro has been doing a lot of robot project like this one, Terrestron, and great, Marcus, thank you. So this was the came out from a part of bigger project called Aberration Lab. That's a passion project we started as soon as we started this quarantine, and how can we work remotely together. And so one of our coworkers had this idea to do robot light painting. And I would like to explain at the end of this session about what this whole project is. But basically, we didn't have a good music source for that project that we are going to do Twitch streaming. So how do we do audio? And then when I was looking at the animation curve that's actually left bottom of this video, I thought it's a really nice curve. So I'm like, maybe I can just use this animation itself to drive music. And that was the kind of initiation of this project. And today, the biggest question I had is to be able to render out this video. I had so much struggle because I had to hit render, record in the TouchDesigner's video side. And also I have to hit record in the Ableton. And the way I was doing was I couldn't make same duration of video and then the audio file. So I had to bring them into After Effects and match so that the timing is correct and then re-render again. So I thought that's a quite tedious process to be able to, I wanted to show this to a coworker, but it took me forever to figure out. And
Okay, so now Jarrett Smith and Ivan Del Sol are going to be getting into it with you, and over to you guys. Thank you so much for joining us today, Aki.
Yeah, thank you.
Ivan, you're up.
Ivan, I think you're up now.
Okay. Sorry, didn't see that you had me here. Okay, well, I'm going to start with Aki's easier questions. One of her questions was how to start a note from TouchDesigner to make sure a note is playing in Ableton. And so just to give a quick introduction to TD Ableton, basically, I've built all these components that connect to different aspects of Ableton Live. And so this is the demo file that comes with TouchDesigner. And if you ever need to understand a feature, I've tried to make examples in the demo file of pretty much all the important features. And so this Ableton song component connects to the whole song. A track connects to a track. A chain connects to an instrument chain, which is down here. Point being that you basically have components that will give you chop data from each chain. And then in the demo song that also comes with TouchDesigner, you can just hit play and you can see all the different things moving as the song plays. So that's the basic idea of this demo file. Her specific question was how to start a note in Ableton. And I have this, I don't have the audio running into the stream, but if you watch the master track over here, you can see that when I send the note, it sends the note to Ableton. And the way I rigged this button is I just created a Python interface that sends MIDI into a track. Generally, the way that I connect to a track with TD Ableton is this TDA MIDI device down here. You put a device in your track, and this, normally this would be used to get notes. I think that's the most common use by far, is when the track is playing, you get this nice chop data of all the MIDI going through that particular track. But you can also receive data in there and send MIDI through your track from TouchDesigner. And so that's how this button here works. And I tried to make, as always, I tried to make the Python interface pretty simple. And you can see in the script here that you just send to the Ableton MIDI component a send MIDI, and it turns on note number 40 at volume 100. And let's see, in the wiki for TD Ableton, you can see all of the different MIDI note or MIDI messages that you can send. So this has a description of all the things that you can do from Python sending into Ableton. One thing to know about this is there is definitely some latency because you have to send through OSC between Ableton and TouchDesigner. So it's pretty difficult to build a sequencer in TouchDesigner that's going to play in real time through Ableton, but it is definitely fast enough to do some cool like sound effects for your projects, and we're working on getting faster connection fast enough to make music from a TouchDesigner-based sequencer. So that was her first question, how to start a MIDI note from TouchDesigner. And then, Aki, the other thing you asked was how to best collaborate with a musician when you've built this TouchDesigner network connected to your Ableton Live set. And then how do you give that to a musician to work on when they aren't really a TouchDesigner person? That was your question, Aki?
Yeah, exactly. Since I'm using robot, just a text data, like of each 6-axis joint values that's moving in the timeline. But that's sending, that's essentially playing music. So how can I, ask a coworker who's not TouchDesigner person, but who's somebody maybe like more Ableton, musician type of person to be able to do, the audio part of work. That makes sense.
Yeah. So I tried to design TD Ableton to be able to do that easily. And so basically all of your connections, if you can see on this MIDI one, you pick the track and the MIDI device that it's talking to. It's all by name. So as long as the musician doesn't change the names of things, they can do whatever they want. And when you load it, connect it to it with TouchDesigner again, it's all going to connect properly. and they can create new stuff. That won't change anything. The only thing that will confuse your TouchDesigner project, if you just gave them the straight Ableton, is if they delete stuff that you're trying to connect to, that'll be gone. But if they rename things that you have it programmed to connect to, that's going to break it. But you'll just have to choose it again properly in the TouchDesigner interface. And because it's name-based, I did have to make it so that names need to be unique. So if they make the same name of a track, and I'll duplicate this to show. When you load it back into TouchDesigner, it's going to warn you it found duplicate names, and then it's going to want to add a number to the end of this. And then, so just to show that, it's going to give you the details in the text port. So if the musician adds some duplicate names that mess it up, it's going to help you fix it. But
and then the musician can also just create new track, and then if I open it in TouchDesigner, it'll just automatically find the new name.
Yes. Yeah, absolutely. So then you can just reconnect things and do whatever you want to with whatever they've added to. So,
and
so
as far as since the MIDI is sent from TouchDesigner, if the musician didn't have touch open, they don't have any incoming MIDI, right? So in that sense, they would just need to, I don't know, play with their keyboard or something.
Yes. Yeah. Exactly. If you're creating stuff in TouchDesigner, obviously, if they don't have touch, it's not going to come in. But I mean, you can also record this. You can record it in Ableton's record mode and just give them a demo bit to play if you need to.
Right. Okay. Yeah, that makes sense.
So, yeah, that's.
Ivan, I think there's an incoming question as well from Libnor Borzaven. Can you control Ableton's transport from TD Ableton?
Yeah, absolutely. It's got a play, stop, and record, and these are all connected to Ableton here. So when I turn on record mode, it's just like you hit this record button, play and stop. Now you can't very effectively scrub and move around the transport here. But what works pretty well, and so what I built a system for is if you set up cue points, there is this cue point system in here where I have these cue points set up, and then you can jump to them. This is all available also from Python, so that you can do fancy stuff with this, or just access it through these parameters. So that's the best way. If you're trying to jump around, the best way is to set up cue points to where you're jumping to. Yeah, and then these controllers, and you have loop controls. So I basically everything that Ableton gives you access to, I kind of made a little interface for, and everything. If you're proficient with Python, you can look at the extensions, and all the promoted functions will help you do stuff if you want to do it in Python as well. Sorry, Jared, I can't see the question. So are they asking more?
Yeah, that's okay. Yeah, I think there's one more from Nafis. Is there a way to map parameters from TD, like MIDI mapping, from a more UI perspective rather than a device parameter end? So to map different clips in session, which corresponds to TD button. Okay, having trouble a little bit understanding the question. Why don't you talk about how you would map a parameter to a value inside of Ableton real quick, like to show the parameter, I guess the parameter component.
So there's a couple different ways here. If you want, there is the deep connection here is there's this parameter component, which you can connect directly so I can see I'm on one Muggy and this pitch device. So this is mapped here to this pitch, and you basically just you set up your pathway to the parameter. There is also this thing called the Ableton mapper here, and I have one on this Effect Rack channel. So Ableton mapper is more of the traditional kind of Max interface where you can pick a parameter to map, and it's anything in your TouchDesigner set when you have this device. So I just clicked map and went to track panning, and then you have both parameter access here, so you can see moving this parameter, I'm moving the track panning there. And you can also access it through a chop, which is what's happening with this other one that I have mapped. I have a chop input, and this is actually, these are actually the fastest way to map to a parameter if you just want to control a bunch of parameters in your Ableton set from TouchDesigner. You should use this because this is actually all going through Max for Live and just setting up the connections for you.
Cool. Let's see if we got anything else coming in.
Yeah, he clarified. I guess he clarified his questions a little bit. How do you fire clips, for example?
Yeah, we're going to get into that in the next part, but I think it's good, Ivan, for you to show the most rudimentary way to fire a clip, both the scene and the clip. Why don't you show that?
Sure. Okay. So the scenes are part of the song object. So in the Ableton song component, you can just choose a scene to fire.
So show what a scene is in Ableton, Ivan.
Okay. So a scene in Ableton is one of these things. When you hit play, it plays all the tracks on that row in the Ableton set. So when I hit this one, it plays all of these. When I hit this one, it plays all of these. And so that corresponds to these parameters on the Ableton song device. And you can just choose which one you want to play, and you can fire, and you can stop everything. So that's the scenes. And if you want to play individual clips, the clips are part of the track object. So you can see which clip you're playing on the track, which is a column here in the set. But if you actually want to fire the individual clips, you'll want this Ableton clip slot component. This gives you the choice. You'll pick your track. So I'm on this track called One Muggy here. And then it will give you a drop down of the different slots, which you can then fire the individual clips here, so you can see what's happening here. So you can see this one's firing the top one, and then I'll fire the next one. And so this is the this Ableton clip slot is the component that you want if you want to be playing different clips in your tracks. And again, you can access this all through the parameter interface, or there's also Python functions to do it programmatically.
Yeah, so I guess the final question from Nefis was, the question is, can you make a digital MIDI controller interface that controls Ableton entirely, like the push does? I think, in general, we're using the same API that Ableton's using to control with the push. They've obviously got their fingers deeper than we do because they're Ableton. So yeah, I mean, theoretically, you could make something like that. You're probably better off buying a push, but.
But the answer is absolutely yes. We use the same interface into Ableton that push and all the MIDI devices that are made for Ableton use. So we're basically, what's happening is TouchDesigner is pretending to be this super MIDI device, and that's how TD Ableton works.
Okay. Looks like Aki, do you have any questions for Ivan? Otherwise, we're going to switch to your third question, which is the question about syncing movies. What do you have any other?
No, I think that's my main question. Next one.
Cool. And as well, Aki, we've lost your volume's getting lower and lower. I'm not sure why, but.
Yeah, sorry guys, I don't know.
It's okay.
Yeah.
There you go. You're back.
There it is.
Yeah, it's the Skype, like, kind of trying to do this auto something.
Yeah, okay, fair enough.
Yeah.
Should we switch to you, Jared, or?
Yeah, so I have to probably accept something. Don't see anything yet. Have you asked me to out there?
No.
Okay. All right. So Ivan was really the one who built this, but I can show you the workflow because I've got Ableton set up better with audio on this side. Ivan, feel free to chime in. We can hear your audio too, right, Ivan?
Can you?
Yeah, we can. Okay,
Great.
good. So, one of the ideas was to just build this as we go, which we could quite easily because this is a really simple setup. But let's just instead, so we don't run into trouble, I'll just step through it. First of all, the first thing that we did was opened up an empty Ableton session. So it was completely empty. And then we opened up Touch. So open up Ableton first, then open up Touch, then go to TD Ableton and drag and drop in a TD Ableton package. When you do that, it's going to pop up a menu, and Touch is going to pop up a menu, and it's going to say, do you want to install TD Ableton? Do you want to, and then do you want to put a master track, a TD Ableton track onto your master track in Ableton? Uh-oh, we don't have a lockup in Ableton, do we? Yes, we do. Oh, no. And Ableton might have crashed. Oh, it's back. Is it back? Yeah. And then in the master track here, it'll pop in this master component, which is the main OS or main connection hub between Touch and Ableton. I don't know if you have more to add there, Ivan.
No, that's about right. That's the master connection that talks to TouchDesigner.
So then, really, what you're going to be thinking to yourself when you start working in Ableton is, okay, what do I want to talk to you inside of Ableton? And Aki's question was, she has, I think essentially the question is, I want to push record and start playing the Ableton session, have it record the first frame of the video and the audio together, and then start writing it to disk in real time, write the video to disk in real time. And when I'm done recording, you just want to hit stop record, and you're going to get your full video perfectly synced. That's essentially the question, right, Aki?
Yeah, that's correct. How's the audio now? It's better?
It's better. It's better.
Okay, okay, good.
Yeah. Okay, so what do we need for that? So what you need to do is just essentially go into the Ableton package, and then just go into the Ableton package and look for what we need. So you probably want a song control, and song control is just the overall like stop and play control of Ableton, among other things like the scene control, which is Ivan already mentioned, is the same as clicking the whole row and triggering this whole scene of different tracks, etc. And then we also needed the track control, I think, or no, it was just, no, we didn't even need that. We just needed the song control, and we just needed a MIDI clip control. And so, so that's all we did was just went inside here, grabbed track, grabbed song, copy, and pasted it out here. Okay, so the first thing I think we decided to do, Ivan, was we wanted to be able to push. Well, first we needed to set up the audio routing. So we know we need the audio to come from Ableton into Touch. And then we need, and so that's you do that with an audio in chop, which I'll get in deeper into how the device is set up. This isn't going to be possible for everyone. You're going to need to have a fairly decent audio. There's a million ways to do it, but none of them are easy, and you probably have to have some kind of audio gear, which I'll show you my setup in a second. And then the audio comes in. The math is, well, this is just increasing the volume. So, yeah, I'm sending the audio to you over the stream here, so it can get a little confusing because my mic's going over there as well. But and then this would go out in and be sent into the movie out file. So the audio from Ableton is live streamed into Touch, and then it's mapped into the movie file out. Then the only thing that we're rendering in this case is just all the MIDI notes from this clip. So this is just the way we yeah, go ahead, Ivan.
It's just a fake movie so that we can see that the timing is matching. So this is just an example. I mean, what Aki's doing, I'm sure, is much more beautiful than just MIDI notes firing. But this was just our example setup so that we could see that the note chop is matching exactly the sound.
Yeah, so all we did was we went into the PAX library and grabbed a beat, the Big Break kit. And so Big Break, and it comes with a drum kit already set up and a MIDI clip already set up. So if you wanted to try this really quickly, you just need the Big Break kit, and then you just grab this MIDI clip and then throw it in. So that's all we did. So this is really, really bare bones Ableton. And then I just took the clip 4 times and I just deleted the MIDI notes. This is all the MIDI notes in that loop that comes out of the kit. And then I just broke it down so it's easier to see the MIDI notes come into Touch. And then once that's done, all you need to do is in the MIDI in component is just grab the track, Big Break kit, and then and then it's going to ask you to put, when you do that, you need to add the TDA MIDI device. And what this will do, quite magically, amazing Ivan, is that if you click TD MIDI device pulse, it's going to add this plugin onto the track that you have selected, and this plugin will listen at this location in the stack of plugins. It'll listen to the MIDI device and it'll send the MIDI notes back to Touch. So it's really quite incredible and amazing, and it's working really well these days. So if I hit play here, we get our MIDI notes. And so that's velocity and the note. So you can see it's note 36, 37, etc. Right? So if I do more, the ones with all the MIDI notes, we can see all of them coming in here. And back to the simple one. So really what we want to see is we want to see these notes come in sync with the audio. So what we thought was the easiest way to prove that we were doing that was to just render the viewer of the chop. So that's the viewer of the chop there. And so this is our video source. Our video source is 1920 by 1080. It's just the MIDI notes. And it's leveled to, well, I don't even need that. The cache we'll get into in a second, and then it goes straight out to a movie out file. So that's how this is all rigged up. If I were to hit record right now, you'll see that the audio stream is connecting to the record shop. And if I turn off record and go to this location, which is on my V drive, we'll see the new file, which is there. Okay, so that's essentially the pipeline we set up first, and then we went back and tried to make it kind of sync well with itself, right? So, so the first issue is that when you hit, if you tried to trigger the record start from Ableton, there's going to be a delay because Ableton and Touch, because of the way that their live API works, it's not on like the main thread, and therefore there's a little bit of variability with the tightness of the events coming across. So instead you probably want to trigger the record start from inside Touch, and then send Ableton to start playing, right? So, so the way that Ivan came up with to do this was to fire the scene. So there's callbacks. So the fire scene, right? Is it fire scene?
No, you're just using. We just decided to use the par exec based on somebody hitting the play button.
No, yeah, that's it here, right? Thank you. So the song device, the song component, TD Ableton component, can fire a scene, and in this case, there's 8 scenes loaded, 1, 2, 3 through 8. So I can fire. Yeah.
Well, we didn't. We ended up using just the play button, so it's not connected to the scene. It's connected to the play, isn't it?
No, I don't think so. It says,
oh, okay.
It says if par name equals fire scene.
Oh, I see. Okay, never mind.
Yeah.
Same thing, because the song starts when you fire the scene.
You're talking about play here, yeah, but it was actually, yeah. We tried both out. So it's nicer with this system because you don't have to start with scene 1 or just start playing. You can pick what scene you want to start with. So in this case, you just pick the scene you want to start recording with, and as soon as you hit fire scene, a parameter execute, just a generic parameter execute that with pulse active will fire the callback, and it says if the button name is fire scene, then tell the movie out the movie file out top to record, to just turn on recording. So it just does exactly what I just showed you. It just comes here and turns on record, and then it starts recording. So you're going to have to come here and upgrade your update your movie file name. Obviously, you could make a nice recorder if you set up all this stuff with scripts. But now, if I go here, notice I renamed it to movie file 14, and we can just call it we can just call it InSession movie InSession. So I'm not going to click record. I'm going to come here and I'm going to push fire scene, and I can pick the scene I want to start with, and then we'll start it up. So boom. Okay, so it should be recording, and it is recording. Okay, so it's not going to stop recording now until this record button is turned off. So I can do that right now. I can just click record off. Done. Movie file is written, so I can hit stop. We can go to disk and take a look. And we'll see that we did our movie out files, the movie out InSession movie. Yeah, it recorded. There's 61 megabytes. So, okay, great. Let's do another take, but this time we want the take to actually stop on when we want to stop, when we hit recording stop side of Ableton. So the nice thing, well, this is one trick. There's a million ways to do this, but all we want to do again is the same thing. We want to tell the and I can delete all this extra code here just so it's not confusing. I can delete all of this here, right? Yes. So there's a callback called onSceneStarted. So when this scene starts, and in this case, when a scene starts, it'll pass in this callback. This callback will get run. And so you just check to see if the name of the scene name is well. And so I didn't know this either. Ivan told me this. You can name your scenes. So by default in Ableton, your scenes are just named the numbers. But if you want, you can right-click on them and go rename, and you can call it whatever you want. So we called this record uppercase stop, and then we look for the name record stop, and if that scene is run, we tell recording to turn off. And so the nice thing with that is because of the way the quantization works inside of Ableton, as long as that scene, record stop, is a stop button, it's going to stop also playing your audio file, your loop. And it'll do that in a quantized manner. So if you just time it slightly right, it's going to wait. It's going to wait, go to that scene at the very end of that clip, and it'll stop recording. So that's how the system works. I don't think there's anything more than that. So let me just demo to you now how you would do this.
Hey, Jarrett.
Yeah.
There was a question from Greg Hermanovic, which is, does Ableton output NDI, which TouchDesigner can accept and grab audio?
No.
No. Sadly, no.
Yeah. And actually, yeah, before we get, well, because we're on this main thought here, let me finish this, and then I'll get back into the audio routing, because I think it's important for people to see at least one version of how we move audio around. And I'll explain how I'm doing my audio rig, which allows me to talk to you guys. It allows me to record audio to disk. It allows me to send my audio from Ableton to you guys, which is a rigmarole, but I can show you how it works. And that does include NDI. So, okay, so just to close this thought up, the way that this works is you have to hit Aki, this is the way it works right now. And you would be able to make this even easier by building a nicer user interface over this, but this is just the workflow, and it was working pretty good for us. All you need to do is go to the movie file, change your movie file name, which again could be automated, and then go to song and pick the scene you want to start recording with. Fire scene. Now we're recording. Okay? And now you can jam. So you can use your push and like jam for an hour if you want. You have a big enough hard drive. And then when you feel like you've recorded enough video, and I'll try to do this just so that I'll try to do this not right on the end here, and you'll see that it will quantize and stop recording right at the right moment. So I'm going to click stop, and it's going to wait, and then it's going to be over, right? So that allows us to capture all the audio and the video together in sync. So we should have a nice clean clip. So to put that to the test, we can go down here to this rig here I have, and I can switch to the audio movie, or to the movie file, and I'll just load that movie file we just did, which is InSession 2, and I can switch this to be 1, and this would go out to you guys as well. Are you guys getting on? Let's see. Can you guys hear audio? No.
Yeah.
Yeah, we can.
Oh, we can? Okay, I just can. Okay. So, so this is the audio this is the file we recorded to disk, and it's probably not going to be super easy for you guys to see if it's in sync or not. But nevertheless, that's the workflow. We also found that it was a little bit off. Timing was a little bit off, and that's because you have to deal with the buffer size of the audio input, the buffer size of the audio coming out of Ableton. You've got to deal with with the frame rate issues between what you're viewing with inside Touch, and so on. So two things to be aware of when you're adjusting your when you want to deal with these delay problems is you inside of Ableton, you can delay your certain tracks. So you could theoretically, if you were ahead, you could delay Ableton's track by, for example, if you wanted to delay it by 1 frame, if you were running at 60 frames per second, then you could just go to 16. How do I type into this? 16 milliseconds, for example, or 33 milliseconds for 2, and so on. And then as well, inside Touch, if you want to delay by frames, then you can use a cache top. And the cache top, we ended up settling on 20 frame delay. So the audio is coming in, it needed to be delayed by, essentially the data needed to be delayed. Like the data is coming in and getting sent into this top, and that needed to be offset by 20 frames to match with the audio. So either in Ableton or in Touch, you can push or shove using the cache top or the delay track settings, and you can do that on a per track basis. So, am I missing anything, Ivan, about this setup?
No, I think that, and I think that we discovered that the cache top was the most effective way to go. And then you didn't show them the sort of visual kind of matching system that we had. Didn't we have it where you could adjust? You were adjusting the cache time real time to get the sound just right.
It's going to be hard to show that, I think.
Yeah. So I guess the point being, this was the tricky part, is getting the tiny bit of offset of timing between Ableton and the audio. But once you get this correct amount of offset, then you can just hit record forever. You never have to do it again. But there's just that initial legwork.
Yeah, so as long as you're running at 60 frames per second inside, or whatever frame rate we decided to run at 30, yeah, once you get that all dialed in, it's very stable. So at least,
and the amount that you cache, it's just depends on your workstation. Just like it depends.
Depends on your audio card. Yeah, your works. Yeah, it'll depend on all the factors that make your computer. So there are going to be different settings. You know, like for example, and so let's get in quickly into the audio routing system, because that's why Ivan couldn't show you this, and I had to, because he didn't have the right setup. So first of all, in Ableton in the audio setup, you can only set one device. And so this is the great limitation of the way that both Ableton and Bitwig work. And it's a major downer, in my opinion, which is that you can only have one audio device set up. And so in this case, I have the Apollo Twin USB. And it's really amazing. I highly recommend it. It's a little bit expensive. But it has a really great, and the reason why I like it so much is because of its console software. So it has 4 virtual channels, and the other Apollo devices have even more. And what virtual devices allow you to do is you can select the virtual channel as an output. So you'll see in my output configuration, I have all 10 outputs are configured both as stereo outputs and as mono outputs. And so what that gives you inside of Ableton is I can direct this main track, which is, there's only one track in this file. I can direct this audio out to my speakers locally. These are going, 1 and 2 is going to my local monitors. And then 5 and 6 is just happens to be the virtual channels. So it's analog 1 and 2, and then there's other channels, but then the virtual 1 and 2 channel is here. So you can see that here if I hit play, and if I turn down my send, I'm no longer, and you guys probably can't hear the music anymore. Is that correct, Ivan? You can't hear the music?
Yeah, I can't hear the music.
And then if I turn it back up, right, you can hear it, right? Correct? Yeah. So that send is sending out this bus. It goes into this virtual channel. And the nice thing is, because Ableton only has an input config and not an output, or sorry, no input is configured on 5 and 6. Then inside of Touch, you can load the ASIO driver here, audio in. I can load the universal audio device, the same device I have loaded as an input device in Ableton. I can load as the same device as in Ableton I have set up as an output device. I can load it as an input device inside of audio, inside of TouchDesigner, and I can pick virtual 1 and 2. And then you want to make sure that the sample rates across all audio in your all devices, all audio devices, everything needs to be set to the same rate. Otherwise, you're going to end up into all kinds of crackling problems and delay problems. You have to unify, ideally, all of your sample rates and also your buffer lengths. So inside of, for example, inside of here, the settings panel, you have to set your sample rate and your buffer length to be unified length. And then that really helps a lot with stability of audio, avoids crackling and stuff. There's a bunch of things there, but so then the audio comes in here, and then it just simply gets put into a null and then mapped into the movie file out, right? So that's the loop. So it just goes through my out of Ableton. It goes to speakers, and it goes to Touch, the same channels, and then those channels go through Touch, gets put into the movie file out, and then you have to hit record at the right time, and you have to hit stop at the right time. That's the whole system. So it's actually quite simple as long as you can figure out all the audio routing stuff. And then from here to you guys, just as a side note, I guess, is since we have 2 minutes left, and then maybe we'll quickly get to questions, but the audio comes through here, comes in, gets mixed with my mic, which is right here. This is my microphone. This is the audio feed from Ableton. And then they get added together, and then they get sent out NDI. So it's the exact same thing again, but just like the movie file out, this goes out NDI, and then from here, it goes into the NDI virtual input, which is here. This is the NDI virtual input. There's an article on this called Broadcasting to Social Media that covers how to install the NDI tools. Then you can send a video stream directly to whatever application. In this case, we're using Skype. And that's how the audio and my voice is getting mixed out to you guys right now. And then, are there any questions? Is anyone reading the questions here? Maybe I'll just quickly go through them. It seems to me.
Roy had an interesting question about recording TD in non-real-time mode for huge pixel formats, which...
Right, yeah. Well, so yeah, I mean, that's the problem. I mean, this workflow won't support that because Ableton doesn't do that, right? So you need to keep them in touch or in sync somehow. You could bounce your file to disk from Ableton, and then you could sync them up inside Touch and then do a super high resolution render. Yeah, I mean, not in this. There's no, well, so that's the other thing that we started with, which actually this is another good point worth mentioning, because this is where we started when we were investigating the right way to do this. You can go to, if you go onto Google and you type in SMPTE audio file generator, you'll get, you can go to this first website and you can say, I need a 30 frames per second, 48 kilohertz, blah, blah, file that starts at 0001. And the duration is 30 minutes. And then click I'm not a robot and click go, and it will generate an audio file for free. Oh, sorry. That audio file can be downloaded if you right click on it, sorry, save link as. And then what you will end up with is a audio file, which is, well, so then from there what you can do is you can drag that audio file into Ableton, and that SMPTE track can be sent to Touch again through the same method I showed you already, through the virtual input, and then you can generate the clock file. So I can do that probably really quickly. Ivan, if you want to read the other questions, you can kind of help me multitask here a bit, and then I'll load that file up real quick just to show it.
Jarrett and Ivan, there's a question here from David Braun, which is, what are Derivative's thoughts on using the engine comp in conjunction with C++ code that generates audio?
What are your thoughts on using the engine comp to generate like sort of dynamic synthesized audio inside of TouchDesigner? I mean, why not? I mean, if it works and it sounds good, then go for it, is what I say. And the engine comp is definitely the way to go forward on that. A lot of the projects that we worked on in the past, for a lot of the big projects that we made in the past, we always had our audio system broken out from the main thread rendering system. And it was always, we always ensured that it was running with a lot of headroom. So there was, we always made sure there was quite a bit of headroom, because if anything in the system, in the operating system, that caused it to chug, then you would get a crackle and pop. And so that's the problem with TouchDesigner for audio. It runs at 60 hertz. If it was a proper audio system, it would be running, those networks would be allowed to run at 40 or whatever audio frequency that you might require. But there's a lot of great tools in there already with the new audio upgrades that allow time slicing to kind of deal with that in a somewhat elegant way. So, I mean, if it works, it works. And in a system like this, you might actually be doing this on another thread as well. So, or on in the engine component. So yeah, I say absolutely. Trying to drag this in here, which is there. Okay, good. So there's not any other questions. I'll just really quickly show you how to generate time code inside of Touch.
It might be worthwhile just mentioning that Owen Curry is asking audio into the engine comp, if this is currently working, as he experiences that his audio components do not work with the engine component.
Yeah, I think those are questions for the forum. That's kind of beyond this stuff, but yeah, we should be able to make that work.
That's really a question for Malcolm and the engine developers then, if something's not working. I don't know if Malcolm wants to chime in, but
yeah, I would say post on the forum. Yeah, definitely. Our plan was that the engine component would be used for audio processing. So if you're having issues with it, please report them on the forum so we can take a look.
Okay, so really quickly, I'm going to send this LTC timecode file that I generated online out to my external out. I'm going to go to virtual output 7, and I'm going to push go. Okay. Stop. I'm also going to go to the console, and I'm going to turn the send. Well, you can see if I hit play. here. Okay, so I can turn the volume out, so it's no longer going to my speakers. And then I can go grab audio in. Audio device in. Then go to ASIO, Universal Audio. You have to type, you will break your sound card. This is really bad, but we don't have a global setting for sample rate inside Touch, so you have to manually set the rate. So you always have to know your rate. You have to type the whole number. It's in kilohertz, so that's also hyper confusing, but that's just the way it works. And then virtual 3, and there's our time code. So then we can go from this time code input to LTC in. And now we've got a frame number. So we can do total LTC frames. And so this is the timeline directly connected to Ableton. So if I, for example, trail it, so you'll see we're getting a perfect timeline out of Ableton. Ivan and I also spent time trying to do the same thing in Max, using Max, and we couldn't figure it out. I still think that there's a solution there, but we don't know how to do it. So if anyone has an idea, let us know. The problem with doing it in Max is that you get jaggies, and so we don't know how to get a perfectly smooth ramp out of Ableton. But so now you'll see as soon as I hit stop here, it'll just tail off and stop here. So you could actually start editing this, I believe. Okay, I want this to be, and then just clip it like that. And then if I hit play, yeah, we're just going to be stuck. Is this not looping? Probably not looping here, but you can just make this one frame. I'm not going to get into that right now, but you get the idea. You can start editing a long SMPTE timecode file, start chopping it up into pieces, and then you can piece together inside of the arrange view, or inside of the session view, you can piece together and have it jump around. Or alternatively, you can take this file and drag it onto the timeline here, and then you've got a locked timeline inside of Ableton here. So if I go here, turn this off, and hit play, you'll see I can now jump around the timeline. So I can jump here, and you'll see a discontinuity, and I can go back and forward in time. And so that's how you would. You have to keep your tempo the same. It has to be locked tempo. It has to be the same tempo for the whole time. Now you've got a locked timeline for recording and stuff. So that's another sort of process you can use. So unless there's any other questions, I think we're good. So we've already gone over. Cool. Okay. Hand it over to you, Marcus.
Yeah, great. Thank you so much. And I hope, Aki, you got some of your questions answered. That sounded like it.
Yeah, thank you so much. Yeah, everything has been answered. And I just wanted to have a quick promotion about this project at BT Pro. The Aberration Lab, this background is a test light painting we are doing. It's going to be launched on the 27th. And you can go to this website called Aberration Lab on Twitch and both Twitter, and you can type in message and robot will draw. And you can also hear the Ableton audio that we are doing on the Twitch stream. So thank you so much.
Thank you, Aki.
Thank you so much.
Thanks, Aki.
Thank you for joining us.
Thank you.
Yeah, thanks for the great question, Aki.
And I guess we're switching right over to you, Torin and Peter.
Hi, guys.
Hello.
So thank you again to Torin Blankensmith and Peter Whidden, developers of ShaderPark, for joining us today. So ShaderPark is an open source web-based platform and community for creating real-time 3D graphics and animation using code. And guys, we're super excited to actually get under the hood of Shader Park. But before we go there, you both have such interesting backgrounds working on sort of big technology and science projects. Could you quickly give us a little background information about yourselves? Peter, maybe?
Sure. Yeah, so I was recently a student at the University of Washington. While I was there, worked on a range of things, like from computer graphics and kind of physics, astronomy, and machine learning things. Did research one summer with some engineers from CERN on their like data visualization software, and published work with some researchers from the Dirac Institute on basically methods for finding new Kuiper belt objects like outer solar system.
Wow, fantastic.
Planets. And yeah, I've done a number of kind of experimental graphics projects. I'm currently working at Amazon on video classification technology.
Fabulous, really. That's a lot of accomplishments. And Torin, you're currently adjunct professor at Parsons in New York City. Oh, you're muted, Torin.
There we go.
There we go. Hi.
Yeah, that's been awesome. That's been such a fun process. We actually just finished up one of our last classes. It was a bit tricky during the whole lockdown situation, but we like transitioned the class to be online, and it was it was actually, I gave them like a pretty short timeline for their final project, but it was really fun, really amazing to see what they came up with. I was totally blown away. I gave them like a week to do their final project just because all the timelines got shifted. It was amazing to see. But yeah, so I've been working as an adjunct professor, and then I also I work as like a freelance creative technologist. But my background was initially in like human-centered design, and then I tried to like combine that with software engineering. But at the time, there wasn't really ever a field of like creative technologists. So it's really fun to see now at like a place like Parsons, a track you can do. And also some of the students have been super interested in TouchDesigner. So it's so incredible to see a community like this that can, allow for the possibility of doing creative coding. And I guess to talk to some of the like more recent things, I do like some installation work. Initially, like more like interactive websites and things like that. But I started working with TouchDesigner professionally for some like interactive installations, kind of like real-time physics sims. And then most recently, I've been collaborating with this team. It's Studio Elsewhere, so shout out to them.
Oh, yeah.
And they've been doing a whole collaboration right now with the Mount Sinai Hospital, and we basically have been like partnering, kind of like formed this organization called Frontline Strong Initiative, where we've been basically building out these immersive recharge rooms for the frontline doctors.
Amazing.
That's been really incredible to see.
That's fabulous, yeah.
Trying to like simulate the experience of stepping into nature and just kind of like taking a moment to decompress for a minute, and trying to like help combat like PTSD and burnout for the doctors. And yeah, that's been really incredible to see.
Amazing. And so what brought you guys together and drew you to developing Shader Park?
We actually met at University of Washington, and then we started a creative coding community. So like, I feel like at UW, like a lot of the people we saw, there was like very few people who were working on creative code. I feel like you would see a lot of like software engineering applications and things like that. But we joined up to start teaching these like weekly workshops where we teach like 3JS, we teach shader programming, processing, or 5. And then as a part of that community, we ended up actually, as a part of that community, what we ended up doing is the initial prototype for Shader Park actually came about from Pete and I think it's Michael doing like an early prototype, seeing what it would look like to view shaders in like a 3D environment, and kind of developed from there.
Amazing. And so since
Pete, I think you're muted.
Oh, Peter, yeah.
Whoops, I say, yeah, the initial experiment was like, can we put a bunch of like different Raymarch objects into one kind of environment, and then it sort of got this like sort of live coding aspect to it of like what if we could just like edit all of these things in the same environment separately. And there was this fun kind of prototype too, where it was like you had an avatar in this like virtual little like space that you would fly around and edit these things individually in.
All right, so that sort of brings us to why we are gathered here today, and how TouchDesigner fits into your future plans. So I'm going to turn you over to Rob McConnell and Malcolm Burchard. And thanks again for sharing this with us today.
Awesome, thank you.
Hey, all right. So yes, so you guys have created a system to import your shaders in the TouchDesigner, right?
Mm-hmm.
So that's what we're looking at here. So it's pretty bare bones, right? Because most of the work is actually done externally inside a node script. But essentially, you bring in, if I'm correct, you bring in your script here into TextStat, and then internally in here, there's a script that fires that runs a node script that ultimately creates a GLSL script that is to TouchDesigner's interface requirements, and that's what ends up working here, right?
Mm-hmm.
Is there anything else that we should show in this file, or?
Yeah, I guess we kind of we set it up as well to be able to have detect live input from the TextStat that's connected to it. So I guess that's on the convert on the far left.
Over here?
No, I think it'd be in the main, the main section. Basically just having it set up so that it would refresh the material every single time that you start typing something new. So you can kind of have live coding.
Okay, that's cool. Yeah, so it's talking to the web page directly also then, or is it just the text file that it's listening to?
It reruns the Node.js converter every time it detects a change.
Right. So do you want to jump into your first question?
Totally. I guess there were a number of things. So basically, we've set it up so we've abstracted the process of doing normally there's a lot of code that you have to write in order to start the process of doing Raymarching or creating any type of content using signed distance functions. So we kind of abstracted it into JavaScript and then set it up so you could write these simple helper functions to start scripting it. And then internally in the project right now, we have it running so that it'll generate the material, but also the text, the output GLSL that you could then apply to a geometry. So I guess there's a number of things that we're curious about. I think one of the first ones is also notice how right below it we have a GLSL element underneath it that we're attaching it to and outputting. But one of the problems is if you go into the actual uniforms for it, what would be amazing is to be able to programmatically add uniforms in. Because when we write our code, we as part of the output we generate basically a JSON format, the uniforms and their default value. So if there's some way to programmatically add that content in, that would be amazing.
Okay, yeah, that's kind of what we were discussing on the side. Let's see. You can certainly generate customized parameters on the fly programmatically within Python from within TouchDesigner. The trick was whether you're getting access to those. But since you're building your shader on the fly, if your converter can actually output a table format, but you're saying there's a JSON dictionary that describes it, so you can read that JSON dictionary into Touch, and then use Python to add custom parameters to your component. So for each of your uniforms, and define their defaults and their names, etc.
Okay, awesome. That's great. Very, very cool. Okay, that's good to know, because Yeah, and I feel like it would be nice. What I'm doing externally right now, if you pop up one layer, you can see I'm basically doing the same thing. If you were to zoom out of the component, you can see that I'm basically just taking the text GLSL, applying it to material, and then we're mapping it to a cube. So I guess that kind of leads me into my next question is like, normally what we do is instead of having like a virtual camera in the ray marcher, what we've done is set it up so that we're using TouchDesigner's camera to like move around it. And when we've done this in WebGL, we take the shader, map it to a cube, and then pass the camera angle in. But I feel like the perspective is a bit funny on TouchDesigner. So we were trying to like lock that down as well.
Yeah, my first thought when looking at it the other day was it might be simpler to actually set it up in a GLSL top, and then do the camera entirely virtually. From our camera component, or even like the arc ball component that's in the palette. There's another new camera component coming, but it's not quite ready yet. You can get access to the camera matrix and the viewing direction and position, which you could feed into your shader. So you've still just got your GLSL top 2D view, but then you can use the virtual camera. And what you can do with like the arc ball camera example, you can take the mouse directions from any panel, so whatever your component is, and use those to manipulate the camera. So you can still get the panning, the zooming, and all of that features without actually building a geometry component and actually having to use a separate cube to map onto. So that's just an alternate approach.
Okay, awesome. That's good to know. Because I think one thing we had explored previously was like just mapping. Like here we just have a single object, but it's also pretty fun to like take it and then map it like multiple of the objects into a space. So you could kind of have the different 3D cubes or the 3D objects like interacting.
Yeah, that's true. If you wanted to like clone it and stuff, and say have multiple instances of your texture in the scene, then then mapping those to actual geometry would be the way to go. So yeah, it all depends on whether you're doing it virtually within your shader or.
Sure. Okay.
But yeah, you also asked about lighting, which
totally okay.
Malcolm can probably answer a little better. I noticed in your shader that you are running it through TD's lighting loop and calling the TD lighting function.
Yeah. So it's like kind of hackily set up. I think I took this approach from one of Matthew Reagan's tutorials, where he just showed how you can like drop down GLSL material and then like generate the script from it. And so we had some of the built-in like lighting models for PBR. Under the hood, I think we had like Pete had implemented a setup where we were implementing PBR lighting, like a PBR lighting model. But then we wanted to make sure that it would kind of like merge nicely with TouchDesigner's setup. So it'd be like making sure that our function calls, we've abstracted it so that like you can call metal and shine and like a value from 0 to 1 for both of those, and then have those like apply the PBR lighting. So it'd be kind of like integrating those together.
Yeah. To chime in there also, one thing that I was wondering about, I'm not super familiar with TouchDesigner's lighting setup, but like in Unity, they have the thing like the Circus shader, which allows you to like hook into their lighting model by like, rather than just outputting like a actual raw fragment color, you can modify materials properties like its albedo and like roughness and metallicity, like those parameters in the shader. I was wondering if something similar exists in TouchDesigner, like way to plug into its own lighting model.
So the shader, you guys are using the Fong. So the function right here that we see being called is the TD lighting. So this is using the Fong model. And so in this one, you can see it has like shadow value and has the shininess value for the Fong. For PBR, if I export a PBR shader. So it's TD lighting PBR as opposed to TD lighting, which was the Phong one. So here the roughness is changeable, right? And the specular color and the diffuse color. So this is kind of how you hook in and change the material properties.
Gotcha.
Very cool.
So that's all part of that function. There, and I think with Phong, there's a few different overloads of that method with more parameters, but with PBR, there's only just one that has all these. So what's missing then? So like for the original question, how to hook in with the PBR lighting. So what do you think is missing right now for you guys to be able to use the PBR lighting model?
I think it just needs to be able to generate the shader that is either like is in some way merged with that with the PBR shader, like in like either it would inject our code into kind of the middle, and then it would just at the end of it we would generate like the lines that would create that shader, but outputting our final material properties onto those values, just like overriding them basically.
Are you looking to do changes to the PBR functions themselves, or just the material, just the input properties?
Probably the material properties is the most interesting part, I guess, just because that allows it to be like more integrated with the rest of the lighting, I think.
Hey guys, question from the chat from Greg Hermanovic asking to explain to us what we're looking at.
Depends what we were looking at the time. That was question.
Yeah, right now this is the shader that actually creates the scene. So with the ray marching technique, basically everything is virtual inside the shader. So the shader generates geometry of the sorts by describing the sphere or the shapes.
Oh, you mean the shader?
And the shader. And then it's doing a ray casting. So for every pixel that the shader is representing, it finds out where that ray hits virtual objects inside the environment, and calculates the lighting. So what was being looked at a few minutes ago was the call where it actually is taking the position and the normal that it's figured out in that virtual scene and applying the lighting model to it. So.
I think here's the ray marching code, right?
Yeah. Yep. So it's basically projecting the ray into the scene, and finding out what it intersects with. So for at least my understanding of it, how combining it with TouchDesigner, you're finding the intersection points of the geometry and the normal of the surface, and then you're just passing that into TD's lighting model, and then you're wanting to control the other parameters, like the material parameters, the shininess, the metal, etc., with the JavaScript code that you've originally, like those shine calls and the theoretically, so you should be able to write those out to uniforms in there that get passed when you're building the shader in that JavaScript code.
Yeah.
Okay, awesome.
Yeah, because right now in your generated code, I think essentially this boilerplate here, you're essentially just throwing it away, right?
It was some indicative grouping.
Yeah, so like essentially this is really what the shader is doing right now, and everything else that's happening inside the main function isn't being used in your code. Yeah, so essentially you would call TD lighting PBR after this before you write the color to figure out the lit values.
Okay, awesome.
Yeah.
Very cool.
So move on to one of the other questions, or so you were asking about the tox file stuff, about how to package it, I think.
Totally. So one of the things that I ran into right now, if you were to like, yeah, what we were trying to do is turn it into like a standalone package. And what we had to do is include in the initial setup our JavaScript library in the same root folder. And then as well as like another extra little script. And so if you...
Yeah, the files you sent us. So you sent us the toe, and then yeah, both your core shader park library and then the convert function. Yeah,
totally. So what I had tried doing initially was bringing them in as text files and then locking them. But the problem, so that way, like when I export it as a TOX file, it would include those, and then like I could just send the TOX file on its own. But then the goal, for some reason, in the Python code, when I was trying to reference that file, it wasn't finding the correct path to it. So it worked fine until I exported it.
Not quite. Can you repeat what the issue was?
Totally. So if you zoom out a little bit and look to the left, you should see two files that are locked. That was like my initial attempt. So I basically pasted the entire library and the other script in. But then programmatically, what I need to do in the larger execution code that's in the middle of this project, what we need to do is get a reference to the path to those locked files. When we're
yeah, there's not a path direct. Sorry, Ralph.
Go ahead.
Yeah, well, that was my only thought really when seeing this question was that essentially saving them to a temporary location on the machine at the time you're compiling it, or like when you detect a change and need to run the script code, and then you could use those references. I don't think there's a good way to get them otherwise from the DAT into Node.js, but I haven't really used Node.js much. So
okay,
yeah, you could use the file out.
Yeah,
and write that script out when you want to be able to reference it from Node.js.
Cool. Okay. Interesting.
So I guess moving on to your last question you had was about potentially a way to build the scripts inside TouchDesigner.
Totally. This would be so cool. So
I had a quick mock-up I can share.
Marcus, do you want to switch over?
So I guess like to give like a bit of background to the question, like now you just, right now you have like a text DAT and you write your code in and then plug it into the Shader Park plugin and then it outputs your GLSL. But what would be amazing is to kind of like preview it almost like a TouchDesigner like SOP kind of, or just in a similar sense where like there's a circle SOP, so like you could imagine having our entire library embedded into a component that would be like sphere, and then sphere would expose a parameter called like with a size that you could change and you could preview it.
So you can see my screen at the moment. Yeah, that's more or less what I was picturing. Now, I don't have the visuals hooked up, so I'm just doing it with text. But yeah, that's kind of what I thought. So where you'd have a sphere component, and then basically the system is passing along a text file. So each component you link in. So the second one that adds the shine, which is kind of back to the material stuff, appends the shine to it, which could be controlled by a parameter there. And then that gets passed along to the next one. So inside each of these, essentially, you take your existing input, you would have a new script generated with Python based on the parameters, and then that gets kind of merged onto your script and passed out to the next one. Ideally, in a full-fledged one, you could have your shader part component as the visualization of each of these, so that it visualizes just what sphere looks like, so that you didn't necessarily have this text view. You could easily also theoretically have a split pane where you have the viewer shows half of the text and the node, kind of like what the web page looks like.
That'd be awesome.
And then you could do, like this one I mocked up could be like a constants. So you could have a list of parameters in the node here where you put in the name, the value, and it adds a variable. And then I mocked up like a loop. Oh, I didn't do the parameters for this, but where you take a second input that becomes the contents of the loop of what gets repeated, and then the loop one basically just adds the framework around that. So yeah, obviously you'd have to take a lot of components to build out all the things you've built into the language. And some things are going to be a little trickier than others. So I was picturing like this one just as a straight text for putting in custom things that might not be as easily represented by parameters. Might still be necessary, but yeah, it seemed viable. And then, as I said, if you had your engine inside each of these nodes, that could have a visual representation instead of just the code.
That'd be amazing. Yeah, I feel like there's already such like a high barrier to entry for like ray marching. Like I feel like I just remember my experience like looking at ShaderToy code for the first time and being like, this is like seeing ShaderToy and being like, this is amazing, and then looking at the code and being like, I will never be able to learn this. Like how does this work? and so
yeah, certainly.
Yeah, and so I feel like
when you put a line of code in front of people, it unfortunately is a barrier to it.
Yeah, sure. So I feel like what we've been trying to focus on is like taking that process and just like simplifying the overall process of getting started with ray marching, and hopefully it can kind of be this like middle ground where like if people learn the JavaScript interface, hopefully they can be able to see like what the GLSL code looks like and start to get a better understanding of how to do ray marching. But doing a setup like this would be really, really interesting, because then I feel like, at least with programming, when you sit down to start using a library, it's kind of tacit knowledge. You're like, okay, I don't know what's available, but if we had them laid out as like a component list, you could be like, okay, I see sphere, I see like union, and you can start to like compose them together visually. I think that makes a huge, huge difference. It'd be amazing.
Yeah, you could definitely easily have components that take two inputs for do a union or some other sort of Boolean operation on yours and stuff. Yeah, it seems all doable. I think could be pretty cool.
And I'll mention a project that kind of did something like this is the TD Neuron project that the Gerritsen brothers did. They've created kind of a node-based interface to do machine learning. So that's kind of an example of building a node-based interface on top of TouchDesigner.
Oh, cool.
That's on GitHub if you want to check it out.
Neuron, okay.
TD Neuron. So it's not quite what you're looking for, but in a lot of ways, I think there's a lot of parallels in that.
Very cool. Awesome.
Cool. Are there any other questions? Or
there was a remark, just what I saw, that Darian Brito also points out Patrick Lechner's ray marching toolkit, which might be interesting to look at as well. I believe I'm not sure what link it has, but.
Yeah. I wouldn't mind actually going back to the one of the earlier questions about how you're rendering a cube, and then can you describe more about the artifacts you're having when you render a cube? In that.
Oh yeah, it looks like So normally what we do is we run the ray marching code, and then you could export it onto like a rectangle. But what we found that was really fun is in WebGL beforehand, what we had done is we just take a cube and then we just map it to all sides of the cube. But what we do is backside rendering. And so you're seeing like the inside view, mainly so that if you zoom the camera all the way into the box or into the cube, you're still perceiving the ray marched object. And I tried to set it up so that in TouchDesigner we were rendering, it onto the cube using backside rendering. Fingers crossed, I hope I set that up right. But what happened is if I pan the camera around, it looks like it's almost like projected just onto one side of the cube and like the back. So ideally, it's just like if it's mapped correctly, you can pan the camera around and you can see it perfectly. Like you can see it as a 3D object.
Yeah. Okay. And is that so? Yeah. So that should work, right? What you're saying. So if I call like, hold on. Is it? I guess they're showing.
Do you want to see your screen, Malcolm? Or yeah, this is mine. I can show you something.
Yeah, well, yeah. If you just want to control it and if you go to the render top and turn on back face or call the front faces on the render top on the advanced page.
Calling.
Pretty
sure. Well, it's on neither at the moment. You actually want to call the front faces, sir?
Get rid of front faces.
Yeah, front faces on the render top on the advanced page.
Totally.
Oh, there's a delay in my feed. I'm sorry. I've done it on screen. I noticed. Yeah. I'm not quite sure why. It's
here we go.
It's catching up.
Yeah.
I did this 30 seconds ago.
It seems like everybody's starting to watch movies at the moment. I think our screen quality is going down.
Oh. Yeah, this might be a little hard to demonstrate when I can't do it live for you guys.
And so what happens now in TouchDesigner when you pan it around?
If you look at like the camera component and you were to like change some of the parameters so that you could kind of like pan around from the side, it looks like, I mean, I guess you can even see it right now if you're previewing it in the geometry mode.
Yeah, that's kind of.
So if you go to that, what it looks like is that it's only like mapped to the inside of like one face of the box. So ideally, it would just be mapped to the inside of every face, and then as you look around it, you could see it from all angles. And the advantage of that is that you could actually then treat it as a 3D object. You could have like multiple ray marched objects in your scene, and then as you move the camera around, you could see each one individually. Instead of kind of this fixed perspective right now.
Yeah, so that should work. You should be able to do that. Yeah, I might have to dig a bit more. Like we probably need an example that's a little more discrete, so we can really see the edges and really see where the errors are versus
totally.
what the parts are that.
The simplest version, if you went into the text stat and just wrote like sphere, I think, but
I don't have Node.js, unfortunately.
Okay.
Quite.
Yeah,
so I can't do it live, but
sure. And that's one thing we're going to look into as well, as like embedding Node.js as a standalone file, so that way you don't have to have it installed on your computer and it'll just run.
Actually, I think it's most likely the issue is with your ray marching code, because you're using the world space position, and you really should be using camera space. You should be doing all this work in camera space, because otherwise you're not going to see the results properly when the camera moves. So I think that's the main problem. I think you need to be doing this ray marching in camera space. And I think that'll make it work properly.
Using that coordinate instead?
Yeah. So you want to take your sculpture center and put that in the camera space, and then take your world position and have that in camera space instead. Do all your basically just make sure all your vectors are inside camera space.
Cool. Okay.
Or or it's either that or the ray direction needs to be converted from the source of the ray direction needs to be converted from camera space over the world space. I'm not exactly sure how to create your world ray direction right now. Maybe
I was trying to zoom in on the code for that, but signal quality is unfortunately dropping a lot. I'm not sure you can read that.
Yeah, it's possible you're already doing that.
For the ray direction,
we could. Sorry, Malcolm. We could try to connect to you again. Maybe that's a better connection. I'm not sure.
Sure.
It's funny. It actually looks very different on a Windows machine.
Oh.
Yeah. That's wild. I could also preview it on my computer if you'd like to, just to show what it looks like.
Yes, we can do that too.
Okay,
You would
that's good,
just let me. What's your handle?
It's T Blankensmith pound 29460078.
I don't have you in my list here.
I think it just hit connect to you on Parsec.
Oh, so I have to connect to you though.
Oh, you do? Okay,
Yeah.
let me hit cancel then. Just kidding.
I don't see your link here or your.
If you go to add friend, I think you can get a T Blankensmith.
There you are.
Yeah, looking at the code more, it looks like you're already converting from camera space to world space for the camera origin.
Okay, cool.
In which case that should be right then. So something else is happening.
So I'm friends with you, but I cannot see you in my list of computers.
Okay. Huh.
What to do? You could send me a link that I can.
I see a setup to join, but I'm not seeing a setup to share link.
Oh, okay. So that might be the problem.
Cool. Okay.
Well, I mean, like you would have to set it up to share your screen, basically, somewhere in the settings. But this I actually don't know. Well, we could just try. Was there something to show otherwise from your side, Malcolm, or?
Well, I guess it looks very different on his screen. So.
Right. Yeah.
Yeah. No, there's nothing different to show on my side.
I thought I saw your computer yesterday, but not so. As if you have to allow other people to share.
Oh, I see. I see.
Possibly under the host settings. First one is enable hosting.
I think on the side I just see computers, arcade settings. So under there I just see like client, network.
Oh, you don't see host?
No, there's nothing for host.
Oh,
Just,
weird.
Yeah. That's okay.
All right.
And Skype sharing was pretty slow.
Yeah, unfortunately.
No worries.
That's giving us not. Yeah, so you don't have a link that you could share, right?
I don't think so.
No, it doesn't say. It doesn't give you the share option. Okay.
Yeah.
Yeah. Well, should we? Was there more or?
Trying to think if there were some other questions.
Maybe I'll connect to you, Malcolm. See if that connects.
There's also there's some questions coming in here. There's time after at the end. Greg is asking you can explain your CERN visualization. He was at CERN before.
So I would guess that he's familiar with like the root software then. So this was just like
Greg.
Like over the project. So I was working on it for a pretty short amount of time, but basically we were using WebGL to they have like a JavaScript. There's a guy named Sergey who's building like a JavaScript version of their root software, which is kind of their whole framework for a lot of their science that they use. So they have a JavaScript version that like runs on the web, and they're implementing like the features that allow them to do like 3D sort of like plots and like render their 3D models in their own in the root format. So we were doing WebGL stuff to create those render. And if I can share it easily with the stream, but if you go to like root.cern.ch/js, you can see some of those visualizations there.
Whose computer are we viewing right now?
I think it's
We're currently
Malcolm's.
looking at Malcolm. Yeah.
Okay. Maybe Malcolm can pull this up.
Sorry, what was the address again?
Root.cern.ch/js.
That's root, right?
Yeah. ROOT.
Is this? Can you see this?
Yes. So you can see some of like there's a number of like interactive like 3D renderings there, which are like examples basically of how it can be used. So I did some help in the this was like, again, this is I think several years ago now, but interesting thing to work on.
Cool.
Super cool, yeah.
Other question.
Let's see.
I mean, David Braun mentioned the fact that a GLSL top can have multiple buffer outputs, so that might be a convenient way to display the intermediate renders of variables.
Interesting.
So that would be like, I'm not exactly clear what he's saying, but potentially as your component viewers might have a buffer, an attribute buffer that you could just take a look at. Might be a nice feature.
That'd be really cool. One thing we're exploring too right now is when we're actually, one thing we were thinking about doing is hooking it up to a GLSL top and setting it up so that we would render the depth buffer, and that way we could have an overlay of, or you could apply the depth buffer to the actual 3D object, and we could get like a nice depth of field look for Raymark content. So we're looking into that, which could be really fun.
Yeah, that should be pretty straightforward to do.
Cool.
As far as the tops are concerned, yeah. And yeah, like with what David was saying, yeah, like very, very often when I'm programming shaders in TouchDesigner, I'll output intermediate values to pixels, and then use the top to chop to analyze the values as a way to kind of see my values in the middle of a shader to figure out where things might be going wrong.
Very cool. Okay.
Yeah. You just got to remember to make your pixel format 32-bit float so you get the full values.
Totally. Awesome.
That's an awesome tip. I love that.
Yeah, with Vulkan, there's print statements somehow.
There are some improvements to the top pixel viewer as well that you can inspect values. Through there.
If you print inside the shader, though, does it just like dump every pixels? It's got to be a lot of output, right?
Yeah, that's a good question. I haven't tried it yet.
I know you can do the same thing in CUDA. You can print, but you don't like. There's a reason that you don't print inside a shader.
Yeah.
You run it a lot of times.
Yeah, that's a good point. Yeah, I haven't looked into exactly what the behavior is. Is there any other questions?
Let's see.
I guess if there aren't, Isabel, would it be possible to show a couple of the videos of like what the renderings are like from the exports?
Yeah, Marcus, can you hook that up? Can you take over the screen?
That's the video that you sent earlier?
Or from the website, right?
I guess that too, yeah.
The website?
Or the website or video?
I guess you do the video. Yeah, the video's got like a kind of general overview of like some of the content.
And we can leave the. Do you want the sound on too, so we can?
Or
do you want to narrate?
Maybe narrate.
Sure.
Okay, narrate. Of course, narrate.
Cool. We don't have to cover the whole thing, but yeah, like I guess this is like the overview of it in WebGL, just kind of like previewing a lot of the different sculptures that you can make. And I guess on the main site, we've set it up so you can kind of go through and click into any of the examples and then like live edit the code. And we've built out some like authoring features for it as well. So you can really easily like start scripting. Like normally there's a ton of setup for ray marching, and you can literally just write a single line of code for this like sphere to get started, and then save it to like a profile and kind of go from there. And we've built out like interactive docs as well. So our goal is just to try and like allow people to have these interactive examples that you can work with. So you can really quickly like change a value and start playing around with the shader code. And it kind of looks, we were inspired by like P5.js and processing for like the actual programming language architecture, just because we felt like that was very approachable to new developers. So we kind of created like a core set of like geometries and modes that you can kick into. So you have like some core primitives you can start playing around with. And I guess from there,
kind of the core of what our goal has become with this project is like there's all this like cool stuff you can do with ray marching, and like it's very powerful and like flexible and has these nice properties, but it's like there's a lot of overhead to kind of work with it as a medium. So like trying to figure out what kind of abstractions would allow you to still get that expressivity and like be able to do as many of those things as possible without having to write as much boilerplate code, and without having to manage as many, have to do a lot of sort of the math and bookkeeping for you in like creating some kind of remarched model.
Yeah.
So sorry guys, I'm not sure, maybe I missed this. I have a question for you guys. So what's your general intention here with regards to touch? I'm not sure I really absorbed that yet. Are you guys trying to allow people to do the same thing, use the same type of code that we're seeing in your editor here inside touch, or?
Exactly. Yeah. So we've set it up so that any of the code that you write here in this editor, you can actually open up in the TouchDesigner component. And so all you have to do is use that text stat, and you can open it up in whatever code editor you want. So, and then put this code in, and then it'll generate all of the GLSL code for you, and you can be previewing it in real time. So we've set it up so you can do like live coding for that. And I've been using that as well to like, what's been great too is like if you want to record a video of it, I usually just like turn off the real-time button and I can like ramp up the quality. And then from there we can like export a really nice like high resolution video. Or it's also super nice to use it for real-time content as well.
So can you, inside of Touch, can you kind of flip back and forth between coding in your higher abstracted language here, like the Java type language, and then get into the actual GLSL code as well?
So we've been at like two main stages right now. When we first set up the programming language, it didn't really generate GLSL code that was that usable, but we've been doing a big push recently that will make the code that's generated in GLSL much, much more approachable. And so at the moment when you put this JavaScript code in and like see the exported GLSL, you can go in and start modifying it. I don't think it'll be quite as usable, but we have a big push coming up that is going to make the code much more readable. So like, for example, any variable that you use here, you could see in GLSL. And what's really great about it right now is that like you can use like functional programming in JavaScript to create a shader. Like you can use recursion, you can use functions, you can use a lot of things like that. So these are, and like what you're seeing right now are like some demos of like, for example, like using the camera's position to like modify the sculpture. So like imagine what you're, and under the hood, they're all using signed distance functions to define the shape. And you can actually like define your own custom signed distance functions. This is actually one that's using recursion as well to make a fractal tree.
Ooh.
Yeah. And we had played around with like some volumetric rendering as well. Just kind of like removing a lot of the initial setup. That's not in the JavaScript setup right now, but we're looking at it. And some other little experiments we had tested out as well were like really quickly generating uniforms. So like you see input at the top, that'll generate a slider for you. So that's kind of what we were talking about earlier is you could it'd be great to be able to generate like a slider in TouchDesigner, but we were looking at like adding in keyframing libraries. And you can see here too, like this is using Runway ML to run like a machine learning library in the browser and pass those in as inputs. Or you could use it to like prototype data visualization. Like this is a hue, saturation, brightness, color wheel that is running as a shader, but it's used to visualize like the Williams College of Art's entire collection of images as kind of like a big color picker. We also looked at like MSDF fonts, so like using sign distance field fonts and then creating a shader from that and like embedding it in a holographic display and like a looking glass.
Wild.
Cool.
Yeah. Super fun. But I think, yeah, a lot of the integration with TouchDesigner, like we had seen like a lot of really incredible tutorials, like Vincent House's tutorial on ray marching, and just seeing that like really, really incredible content here. And so we wanted to try and set it up so that people could hopefully lower the barrier to entry so that people can start experimenting with ray marching and being able to play around with this type of content and kind of be like a bridge between those spaces. Yeah, and I guess one other thing to note too, I just wanted to say like a lot of what made this possible too was like Inigo Quailes's, I hope I didn't butcher his last name, his research on ray marching as well. I think that like allowed us to create this library, and has been like a really incredible resource too. Yeah.
Nice. Certainly.
Very nice.
Yeah, impressive. And so if you go to shaderpark.com currently, oh, I was supposed to change this. Oh no, let me fix that.
Yeah, the URL will change to shaderpark.com.
Right, and when it's currently in a closed beta, right?
It is.
And you're looking at basically opening this up fairly soon, or?
Exactly. So Pete and I just did a really big push recently to make it set up so that the exported code would be much more usable. Hopefully, so that anyone who is like using the JavaScript framework can then learn the GLSL side of it and be able to use that effectively. And I think that would be a really, really great addition. I think recently, yes, and so that once we have that like final push set up, we're going to kind of like flip the switch on it and set it up. Because that way, I think right now, like you can kind of experiment with a lot of the things that you've seen so far using the current language, but we just want to make sure that there's no like backwards compatibility issues. Yeah, and I think we'll be setting it up as like a Node.js, like an NPM module as well. So you could bring it into websites, you could bring it into, and also, I that's one part I'm very curious about too, is like, is there some way of doing like how to host or like bring in the library updates later on, like automatically? I guess I could set it up on the website so you could just like download the TouchDesigner plugin, and then we could include like the newest build of the language through there. I think I might have to answer my own question, but yeah.
Yeah, you could theoretically have inside your talks have a button that even downloads from the web. We've got multiple nodes that can connect to a website and pull your JS script down.
Oh, that'd be awesome.
That's
cool.
doable.
Okay, that would be really good, because then we could like specify a version or something like that in the component, so that
yeah, you can have a web client that and do a function call that says what version you're in and pulls down something.
Awesome. Very, very cool.
I have a question. Do you have plans to do it so you can be programming live on the website and TouchDesigner gets those updates automatically by connecting to your server? So that way you could have like an installation running TouchDesigner, but then you could be doing your live programming on the website, or having somebody across the internet programming on the website.
Ooh, that'd be super interesting. I think our initial approach, I think that we hadn't gone that route yet, because I think there are live programming plugins to VS Code. So right now, since we can make changes to the text stat, and anytime you save it, it'll like live update in TouchDesigner. I think we could do that kind of that like peer-to-peer setup between VS Code. So I think that theoretically is possible right now.
Right, that makes sense.
Nice.
Yeah, I'm not seeing any more questions. Let me ask them.
Never mind, it's on the screen. Good comment. Yeah. Yeah, no, thank you so much for submitting this and for working on this. And that, personally, also the benefit-wise, that so much is that you're abstracting it into something so simple, or much more simple, that takes an initial barrier out of the whole approaching this whole field. And if I saw that correctly,
welcome.
it also translates it into, you can look at the GLSL code on the website as well, right? It does both things, so it's a great way of learning what you're doing. It's really appreciated. Yeah, nice. Really nice.
Yeah, thank you so much, guys, for joining us from
Thank you for having
New
us.
York and Seattle. And please, we look forward to seeing as the development and obviously staying in touch.
Yeah, keep us updated on everything. And
Of course.
hopefully see you at some point in person at a summit or.
Yes. In person, everybody laughs.
Yeah. Awesome. Yeah, thank you so much for having us. It means a lot.
Thank you.
Yeah.
Thanks, guys.
Yeah. So I guess that brings us to the end of our of this session.
Yeah,
only
I guess.
Only 7 minutes over time. That's pretty good.
Yep. So, running off the clock here, synchronized clocks. Yeah, so this was great. Thank you very much for everybody watching. And hope it was informative to everybody. Thanks everybody for presenting and for helping out on the project, preparing the project, etc. This is a good download of knowledge. Yeah.
Yeah, and of course, go to InSession on the Derivative website and send us your networks and your questions. And next InSession will be in 3 weeks' time, and we'll announce the date and program soon.
Exactly. And I think that was a good goodbye word. So
cool. Thank you, Aki, as well. See you guys.
Thank you, Aki.
Yeah. Thanks, guys.
See you guys online.
Have a great Friday.
Have a great weekend.
Thank you, guys.
Bye.
Bye, all.